Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
After configuring this command, this router will regenerate its own router LSA. That I am the endpoint of virtual link. I am the endpoint of virtual link. Let me show you. See.
So the V bit will be
See.
on.
Understood or not? See, this update has been given by 23.1.2. And let me open it now. LS update. This is summary LSA, forget about it. Open next one. Oh, still it is summary LSA. Okay. This is also giving some update here. This is router LSA given by 3333. Okay. Forget about it. Fine. I just configured. See, I just configured this virtual link at the end of R2 only. That this is my endpoint of virtual link, right? This 4444. In same manner, I will move on R4, and on R4 also I will say router OSPF. One area, one is virtual link with whom? The router ID of another endpoint. So this is what? 22222, right? So let me show you just after configuring this command. Now it have stopped to capture your packet due to more traffic. See, just after configuring command on R4, R4 generated one unicast hello packet. R4 generated one unicast hello packet. But after doing configuration at the end of R4, means if you have configured your virtual link only on one end, till that it didn't perform anything, and it will be depending on iOS. In some iOSs you will also find that it starts to show you that virtual link is configured on that end, but this is not configured over here, something like that, right? But here it will be depending on your iOS only. So in some iOSs, what happens that if you configure virtual link only on one end, then it will start to generate unicast hello packet from there only. But this time you see that hello packet has been generated by R4, and it is a unicast hello packet. Remember that over virtual link it will generate only and only unicast hello packet, not only unique hello packet, all packets, whether it is update, it is DBD, it is LSR, whatever it is, it will always be unicasted.
Yeah.
Because you want to send information from R2 to R4. If you are multicasting it, then it will be received by R3 only, and R3 will not advertise it in the direction of like R4. For an example, if you have sent some information with using multicast address from R2 in the direction of R3, R3 will accept it, but R3 will never advertise it in the direction of R4. That is why it is mandatory that in case of virtual link, whole information will be unicasted. So this time you can see that hello packets were unicasted. Then immediately see hello packet was generated by R2, is not it? See R2 because 23.1.2 is there. See, that is why source is 23.1.2. The next hello has been generated by R4. It is also unicasted. Then DBD is generated by R2, and it is also unicasted. The next DBD is also next hello is also generated by R2. It is unicasted. Next DBD is also generated by R4, unicasted. Next is generated by, then LSR is generated by R4. Then another request is generated by R2, and then they have given update to each other. They are also unicasted update, right? Finally, they have exchanged their updates with each other. Now, it has proved that when we configure virtual link on both sides, they will start to send unicast hello packets, right? They will start to send unicast hello packets. Fine. Now, thing is, because I said that whenever an update, I mean, if you talk about the route, this virtual link information, it is always contained by router LSA, because VBit is there, virtual link endpoint, right? So this time let's do one thing. This update is generated by, let me show you. This is also summary LSA, that's not good actually. Wait. This router LSA is generated by R2. Where are flags? This is B is border virtual link endpoint must be there. Only B bit is there. Actually, the problem is that it didn't capture the router LSA. Okay, let's do one thing. Say on R3, say clear IP OSPF. Oh, but it is not capturing anything. Just wait for a moment. Just wait. Fine. Guys, try to see it now. Update is there. And I'm gonna stop it now. This update packet, ls update, this update is generated by 23.1.2. let me open it. Router LSA is generated by 2222. This inside multicast itself you will get that actually. Wait.
That
should have shown me. Source is 23.1.2. My God. It is not showing me that V bit, but it should have shown me. See, you will not find that V bit inside those LSs which are going through virtual link. No. Even if you are having a router LS in the database of R3, of R2 as well as of R4, because R2 will generate its own router LSA for area 1, R4 is also generating router LSA for area 1. So whenever R2 will generate its router LSA for area 1, in that router LSA it will specify this V bit, so that routers can come to know that okay, here virtual link is configured in this area. And when R2, because R2 is receiving router LSA of R4 and R4 is also receiving the router LSA of R2, right? So R4 can easily come to know that what is the endpoint of virtual link. That is why we are specifying the router IDs, because by using router ID, it will check its router LSA. Like if I am saying on R2 that okay, my virtual link is with 44444, so it will check the router ID. I mean, it will check the router LSA. Let's move on R2. And let's check its database, so IP OSPF database. So it will check the database table of area 1, and inside area 1, inside the database table of area 1, it will check that is there any 4444. So yeah, it is. Yes, it is, right? In same manner, you configured it on R4. On R4 also, after configuring virtual link, it will check the database, because you configured virtual link inside area 1 with 2222. Show IP OSPF database, so it will check the database table of area 1, and then it will see that is there any 222. So yes, it is. And then one more thing, same as GRE tunnel, virtual link also creates a virtual interface. Same as GRE tunnel, virtual link also creates a virtual interface. Let me show you. On R2, show IP OSPF interface brief. You check it out. See, virtual link is there. VL0, same as tunnel interface. But to tunnel interface, you allocated an IP address from different subnet. Do you remember 192.168? But this time, this virtual link will pick that IP address automatically. Don't say that it will pick the IP address of serial interface, outgoing interface. It will pick outgoing interface address as its own IP address. See, OSPF will also allocate an IP address to your virtual link as well. However, still if you say show IP interface brief, here you will not get this virtual link. But inside show IP OSPF interface brief, you will get it. And this IP address is also configured on serial 1 by 1. So basically, here on R2, on its virtual link interface, it have allocated an IP address as 23.1.2, and by default, what is the network type of virtual link? Is point to point. What is the cost of it? 128. Hello. Now, if you check, let me show you. Show IP OSPF neighbor. Let me show you that it is having neighborship with 4.4.4 from R2. It is having neighborship with 4.4.4. This is the router ID. This is the neighbor's router ID, but the actual IP address for which we are having neighborship is 34.1.1.4. It means the IP address on R4 for its virtual link is what? 34.1.4. Check it out. Move on R4 and say show IP OSPF interface brief. and by default this virtual link will be member of area 0. So we always says that to become an ABR, at least one interface must be in area 0. So this time this requirement has also fulfilled by OSPF. It has put this virtual link interface inside area 0 itself. Show IP protocol. So see.
So IP OSPF.
It's not it.
Virtual link.
It is having number of interfaces is what? 1, which is virtual link itself. Hello.
Yeah.
It says that R4 is having one interface in area 0, which is virtual link itself. As you can see, show IP OSPF interface brief. So same as GRE tunnel, now they have created virtual link. What?
So virtual link at endpoint.
Yeah, of course it must have this information. This area has transit capability, virtual link, endpoint. But the thing is, like, it should have this flag on in its router LSA as well for area 1. Like here in the database table of R3, show IP OSPF database, still it is having database of area 1 only. See, because this R3 is participating in area 1 only. Hello, this R3 is participating in area 1 only. That is why it is having database of area 1. So in its database table you are having router LSA generated by R2 as well as router LSA generated by R4, and because it is having router LSA generated by R4 as well as R2, so inside those two router LSAs you must get that V bit, so that it can also come to know that, okay, as you can run this command here, show IP OSPF, this area has transit capability, because you know very well that what is the meaning of it, right? Because this area have become now transit area, because this area is having now virtual link endpoints. So how has it came to know? By looking at router LSA, and inside router LSA it find V bit inside the router LSAs of R2 as well as R4. However, we didn't find those flags inside the update packet, inside the packet which was captured by Wireshark. But here, as you can see that here it is having this information, is not it? If you go to R6 and if you configure the same command here, show IP OSPF, is it showing you that command here that this area is transit capable or something like that? No, because you have not configured any virtual link here on the top of this area. If you configure virtual link on the top of area 2 as well, then also it will start to show you that, okay, this area also have transit capability. So like on R3 it was showing you. Hello.
Yes.
So this time you configured virtual link over area 1. So on all routers of area 1 you will get this message or this configuration. However, you can disable this feature of this transit capability. I will let you know that in which conditions you will require to disable this feature. Hello. Try to understand. I will also let you know that in which conditions we will require to remove this transit capability. I mean to say we can remove this transit capability actually.
सर अगर मैनुअल समराइजेशन करेगा तो ट्रांजिट एरिया में समय जल्दी को नहीं जाएगा.
Of course, it will go. How? I mean, you are saying that summarization, you wanna configure like summarization on R4 for the prefixes generated by R1.
R2 पे या R2 पे समरी कॉन्फ़िगर हुआ.
Don't worry, I will show you. We will perform summarization as well.
चलता नहीं है.
जाएगा.
काफी
जाएगा.
और करके देखा.
Are you okay with it? So this area have become now transit area. That's cool. Now thing is like on R2, guys, try to understand. R2 started to send unicast hello packets 434.1.1.4. How R2 came to know that okay, it has to transmit hello packet to the 34.1.1.4, or how R4 came to know, like R4 generated first hello packet, unicast hello packet, and destination IP was 23.1.2. Do you remember?
Yes.
Destination IP was 23.1.2. So how R4 came to know that okay, it requires to send hello packet to 23.1.2 only? See, by looking at database table. So IP OSPF database router LSA generated by for area 1, because you configured virtual link inside area 1. So it will open router LSA of 2222 inside area 1. Let me show you. This is for area 0, but we have to see for area 1. So this is the area 1. See, this is area 1's router LSA generated by 2222. It came to know that this device is having this IP address, which is participating in area 1 itself. That is why it is started to send unicast hello packets. So basically, this virtual link is also kind of tunnel. Are you not getting my point? This virtual link is also kind of tunnel. Like we configured GRE tunnel, it is also working as a GRE tunnel, but the only difference in between GRE tunnel and even for GRE tunnel, I also configured those tunnel in area 0 itself. Here virtual links are also configured in area 0 itself. So there is no difference in between virtual link and GRE tunnel, but there are some small differences. Like virtual link is always configured as a demand circuit. Even GRE tunnel was also point to point, don't worry. I mean, network type of GRE tunnel was also point to point, same as virtual link. Like in virtual link, its network type is by default like point to point. Fine. Now remember that virtual link will always be configured as a demand circuit. Even I can show you on R4, show IP OSPF interface. See, show IP OSPF interface. First of all, it is showing you virtual link. Line protocol is up. It means this is virtually created. This virtual interface is existing here. Network type is what? Here it is showing you virtual link, and post is what? 128. And state is what? Point to point. And it is configured as a demand circuit, and it is running as a demand circuit. This is the main difference in between GRE tunnel and virtual link. In case of virtual link, I mean, virtual link will always be configured as a demand circuit. Virtual link will always be configured as a demand circuit. Now you will ask me that what is the meaning by demand circuit? Remember that if you are having your neighborship over demand circuit, hellos will always be suppressed after neighbor formation, after neighborship formation. So right now you can see that do not edge LSA allowed. Second thing, neighbor count is 1, adjacent with the neighbor with this, and hellos has been suppressed. It means now it is not sending hello packets anymore to its neighbor 2222. As you can see, show IP OSPF neighbor. Try to understand it. There is no dead interval available. You know why? Why dead interval is not there? It's not virtual. Means if it is a virtual link, then it will not have dead interval over here. Huh? No, it's not. It's not really. Because virtual link is running as a demand circuit. So whenever you will configure anything as a demand circuit, any link as a demand circuit. So previously you can, by default OSPF is running virtual link as a demand circuit. Even you can also configure any normal link as a demand circuit as well in OSPF manually. So whenever you will configure any link as a demand circuit, hellos will always be suppressed just to reduce bandwidth utilization. Just to reduce bandwidth utilization. But remember that before, till the formation of neighborship, it will keep on to send hello packets. But once neighborship will come up, then it will suppress hello packets. As we saw that first of all they exchanged unicast hello packets, but then after formation of neighborship they stopped to send any type of hello packet. Unicast hello packet. Have you understood it or not? Piyush?
Yes, sir.
Virtual link will always be configured as a demand circuit, and if you remember, we configured GRE tunnel interface in area 0 itself, right? And by default virtual link is also configured in area 0 itself, as you can see here on our show IP OSPF neighbor. Sorry, show IP OSPF interface brief. So now what happened that R2 and R4 have formed neighborship in area 0, and because R2 was already having complete database of area 0, and now R2 formed a neighborship with R4, so R2 is gonna to hand over that entire database of area 0 to R4. R4 have also started to participate in area 0. It means R4 will also generate its own router LSA for area 0. It will also give it to R2. So this time there are 3 routers who are participating in area 0, and all of them, now all of them will generate router LSA for area 0. Have you understood it or not? So because now 3 routers are participating in area 0, so 3 router LSAs will be available in area 0 database, in the database of area 0. Now, as I said that if your link is configured as a demand circuit, then hellos will always be suppressed. Fine. But along with that, DNA bit will also set. DNA bit will also be set onto all those LSAs which are going through virtually. Which are going through demand circuit. Remember that whenever any update, any LSA will go through the virtual link. I will not say virtual link, I will say demand circuit. Whenever a LSA will go through the virtual link, DNA bit will be set onto it. You know why? Because by default OSPF sends periodic updates after every 30 minutes. So if you have configured virtual link over area 1, so in case, let's say that again it is required to retransmit your updates after, or you to refresh your LSS just after every 30 minutes periodically, right? So in that case might be the bandwidth utilization of area 1 will be higher. So remember, virtual link is by default configured as a demand circuit, and if any link is configured as a demand circuit, then by default hello messages will be suppressed after formation of neighborship, and also DNA bit will be set onto all those LSAs which are received through virtual link, which are coming through virtual link. Have you understood it or not? So that in future it will not be required to retransmit or refresh your LSAs after every 30 minutes periodically. Tell me. So now, because R4 will receive some router LSAs coming from R2 via virtual link, and also some summary LSAs. So you do one thing, move on R4 and check its database now. Show IPOSP database of area 0 itself. DNA bit will be set onto those LSAs only which are participating, which are in area 0 only, which are coming via virtual link, and via virtual link only area 0's database will get transferred. Hello? Yeah. Because virtual link is configured inside area 0 itself, right? So this time you can see that how many router LSAs are available inside area 0? 3. 1, 2 and 4. Because 4 is generated by itself, it is not received via virtual link. That is why there is no DNA bit set onto the router LSA of R4. But the router LSA of R1 and R2 is received via virtual link. That is why DNA bit set onto that. And its timer will never get expired. It will always remain as 178 and 1 only.
But area 2 की तो जाएंगे.
Wait. Just wait. Right? So this time DNA bit has been set onto them. Now, it received some summary LSS as well from R2. You see? And DNA bit is set onto that. Because if R2 has generated any summary LSA for area 0, it means they will come through virtual link. That is why DNA bit is set onto them. This 23s, 30s, 34's network, 40's prefix as well.
So if we check in R2, the DNA bit will be for router 4.
Yes. I mean, like if you move on R2, show IP OSPF database, see, check the database of area 0. You see that router LSA coming from, I mean, R4 has given this router LSA to R2 now. That is why this DNA bit set onto it, because it is coming via virtual link. Are you getting my point or not? Even R4 also generated some summary LSAs too, and those summary LSAs are coming back to R1. So DNA bit also set onto them, but generated by R4 only. See, and via virtual link only area 0's database will get transferred, will get exchanged. Now, see, because R4 is having at least one interface in area 0 which is required to become an ABR, and also it is having entire database of area 0. So what will happen that it will put LSAs from area 0 into the database of area 2 as well. This R4 will put or will inject routes from area 0 into area 2 as well. So IP OSPF database, check it out. Do not check the area 1's database, check the database of area 2. How many router LSAs were there in area 2? Is there any DNA bit? No. You know why? Because they are not coming via virtual link. It is also having some summary LSAs generated by R4. Are they coming via virtual link? Are these LSAs coming through virtual link? No. That is why, because these are generated by R4 itself. You know, R4 received it via virtual link, but finally whenever they will be injected into area 2, they will be injected by R4 itself. That is why there is no DNA bit set onto these LSAs of area 2. But remember, whenever LSAs will be injected from area 2 into area 0, and then it will give them to R2, then R4 will give them to R2. So in that case, on R2 inside the area 0's database, you will see that 60's prefix is coming generated by R4 and DNA bit is set onto it. Understood or not? But whenever area 0 will give these LSAs to any other area now further, like area 3 or area 4 or area 5, this DNA bit will be stripped. This DNA bit will be removed. Like for an example, if you move on R4 itself, we saw that inside area 0, DNA bit was there for 20's network, is not it? For 10's network as well. Where is 10's network? It's coming inside the router LSA actually. It's coming in the form of router LSA actually. And see, DNA bit is set, right? But whenever after breaking up this router LSA into summary LSA, it has put those prefixes inside the database of area 2 now. But you see, is there any DNA bit now? No. Because whenever this time will get expired, it will be expired on R5, it will be expired on R6. So R5 and R6 will ask to R4 only to refresh these LSAs, not to R2.
Yeah.
Because R5 and R6, I mean area 2 is getting these prefixes from R4 itself. So whenever they will ask for refreshment, they will ask for refreshing LSAs, regenerating those LSAs. That request will not go through the virtual link. That request will come to R4 only, and R4 will refresh it by itself. That is why DNA bit is not there. When LSAs are going from one area to another area. Remember that DNA bit in virtual link, right? In virtual link, DNA bit will be set onto the database, onto the LSAs of area 0 only.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF guys. See you later. Thank you.